In this section, we're going to look at the different ways that processing can work with images. In order to do that, we're going to use PImage. PImage is a data type that can store images. The common file types that we'll see here are GIFs, JPEG, TGA, or PNG. And in order to bring an image into a processing sketch, we're going to use the code load image. And then we're inside the parentheses, we're going to put inside of quotes the exact file name, including the file type. Images, like shapes, need to be in the data folder of the sketch, unless otherwise specified. And when we're in draw or in the code somewhere else, and we want to call an image, we'll use image, and then the different parameters or arguments here are the variable of the image, the X and the Y position, and the width and the height. If you don't specify the width and the height, it'll just use the width and the height of the original image. And one other thing to consider is loading an image can be slow because it's loading the pixels. Sometimes images can be quite large, and so this should be done inside of the setup. And in fact, when you start loading an image, you'll see the program kind of hangs a little bit because it needs to actually bring it into memory. So let's look at some examples of that with code. Okay, so here I have a new sketch. I've actually saved this out already, and I've already included an image in my data folder. The way you could do that is, you need to save your file first, and you can add a file here, or if you're in Finder or something, you create a folder called data, and I have an image here that I'm going to use, and I'm going to load, and here's that image. Okay, so that's a picture of a dog, and the dimensions are 600 by 800 pixels, right? So it's important to know that ahead of time. We're going to start by using PImage. It's a capital I, and so this is a data type. We need to give it a variable name, so we'll call it IMG. It could be whatever you want it to be. Let's start with that. Okay, so we'll create a void setup, and I just want to load this image. I just want to kind of start it off slow. I know my image is 600 by 800. And if you are going to be using images, you probably don't want like a 5,000 pixel image if you're really going to do something small, right? Now I want to do load image, and it's camel case, so lowercase l, capital I. And inside of here, I will call up my file, stella.png. There you go. So that's here. That's loading that. It's in the data folder. And let's see what else we would need to do. I think that's really all we need to start with. And inside the draw, I'll just put it in the draw for now. But this is going to keep running. I could have just put it in the setup if it wasn't going to run at all. So what's the file? What's the variable that I want to draw or draw on the screen, and then what is the X and Y position? We'll say 0, 0. I could say 600 by 800, but I already know that's going to fit, so I don't really need to say that. Let me just run it, and this should just, all it does is show me that image I have there, just to show you if I put in other values, like let's say I put in half the value, 300 by 400, I can draw it down into a smaller size. We've got that, and if I wanted to do mouse X and mouse Y, again, just to show you, these are things that we've done before, but we're kind of applying it to an image. Oh, here's the image, and oh, that's kind of a trippy dog scene. Okay, so that's some basics of loading or using PImage. Let's keep playing with images a little bit more. The next thing I'm going to try to use is a function called tint. Now, tint can do different things depending on the number of arguments we pass into it. Let's say we just pass one number into it, and let's see what that does. So originally we had that color image, and what's happening now is that it's affecting the brightness. It's making it a little bit darker. That's 100, but let's say if we made it 255, what would that do? So this is the full brightness, and again, if I brought it down to 0, There you go. So the 0 is completely dark. So this is a way to kind of tint the image. If I put in 2 numbers, maybe if I did like 150, and actually let me change this to mouse X and mouse Y so you can kind of see what happens. We're gonna get the image and it's gonna have this opacity to it. So that 50 is affecting the opacity of that image. Okay, so you can kind of see that. And if I'm, let me make it even more drastic. Here it is at 10, and you can see it's even more faded. So this could be something to play around with images. And then if I went with 3 numbers, let's do 3 numbers. Let's say I wanted to make this all red. I could do 25500 because that's red, right? We're in RGB mode. If you wanted to be all blue, you could do 255, and yeah, here we have a blue version. And I believe if we put in a 4th number, we should have that opacity as well. So there we go. So blue. Okay, so that's one other thing to look at. Let's comment that out. I guess we can still use mouse X and mouse Y. The other thing, and I think we've gone over filter before, but you could run in different arguments again, the type of the filter, and usually there's some sort of option that you could do. So we have a posterized filter that might, lead to some interesting changes. Oh, so what's happening here is the filter is running, it runs on all the other stuff that a previously drawn image. So actually, if I want to have this be the very last thing that gets done, I'll put it at the end of it. So now you can see we are posterizing this image. I think there's a blur filter. I think I might need to put some parameters on it, there's a little, it is blurring it out. I haven't put any parameters on it, but or arguments into it, but I could change that. Okay, so I'm gonna just on processing.org there's a list of different filters, but I'm just gonna pull up some other ones while I'm here. Here's the invert filter, so it is inverting in between these different things. Okay, in this example, I want to show how to load some images into an array and then reveal them using that array. I have created a sketch called image array, and I have some files in my data folder. These are some photographs of mountains taken from Unsplash, and I have just the author's or the photographer's name, and I have a number sequence here because I want to load them sequentially using a loop. And notice that I'm starting at 0 because, again, an array starts at 0. The index starts at 0. So let's go ahead and start making an array from this. We'll have the data type. We'll do the square brackets equals, the name of the array is images. Could be whatever you want. New PImage. And how many are there? They're going to be 4. So we'll write 4 there. I've already set the size here to the size of these images. I made them smaller so they wouldn't be too huge. Again, really pay attention. You don't want huge files here because it's just going to bog it down unless you really need that high quality. Okay, let's make a loop here because we are initializing the array. So I is equal to 0. While I is less than images.length I++. Okay, and here we're going to load up the array. We'll say load image, and what I can do is take the first part of this file name, and because it's the same as the other files, and I'm going to kind of string or connect some strings together. So I'm going to plus, and I'm not adding things because this is a string here, and what I'm going to do is take this I, in the first time it runs through, it's going to be 0. So imagine this text and then a 0 there, and then we also want to add-on or append dot JPEG, right? That's going to let us load that file. And the great thing about that is as it goes through the loop, it's going to update. So the next time it's going to be -1, -2, -3. So if we had, a bunch of these, 50, 100, whatever, you could get that set up. And if you you could use a renaming tool or batch operation or like an automator. Okay, so I went ahead and did the rest of the code because I think the most important part was understanding how to set this up. I wrote, I ended up creating a counter that would keep track, sort of like the index, and I've used that here inside of the image function when I'm calling the images array. And every 30 frames, I'm advancing the counter. I'm using modulo here. Whenever modulo is equal to 0, I'm going to add 1 to the counter, and I also want to make sure I reset the counter if it goes too high. And so if I run this, it should just be kind of like a slideshow. And so that's one possible way to go about it. We could also, maybe we'll even do something like int timer is equal to 30. You could make it more random by maybe using a random variable here, or using a variable timer, and maybe every time it gets triggered, timer becomes some random number. So we'll do int because it needs to be turned into an int, but maybe we'll give it a range of like 10 to 60 or something. So that could be interesting. It no longer is super like consistent, but it's kind of like bouncing around. So it's kind of creates this animation, or random animation. The next thing I'm going to talk about is pixels. And I think this is something we're probably familiar with. When we look at an image, it's composed of picture elements or pixels. They exist in a two-dimensional space, sort of in this grid, X and the Y. And if you get really close to an image, right, you'll start to see those pixels. One of the things that we can do in processing is access the information that's encoded in the pixels. We can access what's called a pixels array. And what that means is, the color value of each pixel is stored in a one-dimensional array, which is a little bit maybe counterintuitive when you think about a picture being a two-dimensional space. So armed with that knowledge, we'll be able to reference pixels and pull their color information and brightness and things like that. And in doing so, we can start to do some image processing and image treatment. So let's look at some examples of that. I'm going to use the sketch that I started earlier, and I'm going to start to show you ways to access that pixels array and access the information. So this is that sketch that I was working on. What we want to do is create a loop and go through and actually kind of go through that pixel array. Remember, it's a one-dimensional array, and start to access that information. So I've already written the code just to speed things up. I need to load the pixels array here. What I'm going to do is run a loop. Now, what I can do is, just as with an array, I could access the length. I can access certain properties with the dot syntax here. So what I'm going to do is, have my variable img, my PImage variable, and I'm going to access the width of it. And so what I'm going to say is, go through there, but only go for as long as there's a width to advance through. And what I'm actually going to end up doing is, I could go through every single pixel, and if that was the case, I would do x++. But I actually created a variable called cell size, in this case 20. So I'm skipping 20 pixels because I kind of want to make like a square, like a pixel grid. Take that image and actually purposefully make it look pixelated. So I'm going to use that as the kind of the shift over, and then inside of this other loop, this for loop, I have y. So I'm going to access the height, and I'm only going to go as long as I'm still within the image's height. Now, what we're going to do is create this new variable that it's kind of like it's the array index, right? Now, the way that we're going to convert this two-dimensional image into a one-dimensional array, pixel array, is, what you'll do is you'll take x plus y times width. So here's a diagram kind of showing a pixel grid and also the pixels array. And again, inside of these boxes, we have the array index. And so, or the index, and you can see that on the right, that's the pixels array. Here on the left, we have kind of, imagine like an image, and we have labels, like the x and y values are off to the side. So at the top, you'll see 0, 1, 2, 3, and on the left, you'll see 0, 1, 2, 3. And to calculate the array index, what we'll do is we'll take the x value plus the y value times the width. In this case, it's 4 pixels. So we're just counting over 4. So let's say we wanted, the bottom left-hand one. Well, it's x, which is 0, plus y, which is 3, times 4 pixels, which is the width, and that would be 12. So that's a way for us to calculate the index of this pixels array. And then we're going to use that variable, LOC or loc, as the index of that array. So the way we access the pixels array is the name of the variable, in this case img dot pixels, and then we have the array index here. So we have what we can do is pull out things such as brightness by running the brightness function on that, and then we're gonna throw that into this float bright. We could just grab the color itself, C. Now this is going to give me the sort of already like RGB altogether value, or we could grab separately the red value by running the red function, the green value by running the green function, and blue. And so this is a way to kind of break it down. And what I'm going to do now is I'm going to comment this out. I've already pulled the color C from the pixels array, and I'm going to use that to fill in a rectangle or a square in this case. And this is going to give me that pixel-like grid that I referenced earlier. So this is a way for me to go analyze the pixel, pull the color, or brightness, or red, green, blue, and then use that to start to draw with. And again, I could go into the cell size and adjust it. Maybe I make it smaller or bigger, or I can do other things with it. So this is a really powerful way to access the color information. Image grid. Now I'm using triangles instead of rectangles, right? And you can use any shape. You could use circles, or you could grab that pixel color and start to draw with it. So let's take a look at this. It's again, the basic structure is the same. We have PImage up at the top. We have cell size to kind of help drive how big that triangle grid is going to be. The code is a little bit different here. We actually have some integers for columns and rows. We have the size. We load the image. The columns are defined by taking the width and divided by the cell size, right? And the rows, kind of similar thing. There's just a bit of code here that I didn't include in the previous example, but technically when you access the pixel grid, or if we want to change the pixel grid, the pixels array, when you either want to read or write to it, technically you should run this code. My code ran without it, and actually if I took this out of here and it did run, but I just want you to be aware of this function. You actually need to load the pixels. Again, use the name of the variable img. All right, and then we're going through. So the loop is a little bit different. What we're actually doing is we're using the number of columns to kind of run through the image, but then we're doing a conversion here. We're getting the x value by sort of like multiplying the columns by the cell size, and the y value by multiplying the rows by the cell size, essentially, right? The j and the rows, the I and the columns are kind of mapped to each other. So again, what we're going to do is grab the color here by accessing the pixels array. Let's see, and we're using that fill, And then, we have two triangles here. One is, this one triangle is sort of a triangle that is pointing up. And then what we need to do is shift over a little bit, because the triangle, it's like teeth, they're like kind of moving into each other. One triangle is pointing up here and one triangle is pointing down. So we need to kind of shift over a little bit and grab that pixel value. And then the way that we draw the triangle is a little bit different. We draw it facing downwards. So that's what this code is doing. And this code will be available on GitHub, so you can take a look at this as well. Okay, so as an assignment, now that we've gone over how to use images and access the pixels array, I think a good assignment is to try to create your own portrait or self-portrait, and use code to draw it, use shapes. I'm going to start with an example. I'm going to use the same image, and I'm going to start to, I'm actually going to work in 3D and add some sine waves and noise and some things that we've been doing before, and just try to have fun with it. I'm going to start from a template file that I've created, and this is also going to be available on GitHub. This template file, it basically allows me to create a PDF while I'm in 3D mode, which is a little bit different, and it's also going to use a timestamp to name the file so that I don't save over it, and it has a unique name. So let me just go over this code real quick. There's the processing PDF library. There's this other Java library that will import. We have a Boolean record that kind of turns on and off to record a single frame. We set P3D up in here, and for the record section, normally it's begin record for PDFs, but because it's a 3D PDF, or it's a PDF that uses this 3D mode, we're going to use begin raw. And what we'll do is we'll save it as a PDF, and we'll use this timestamp function, which is at the bottom. You see the timestamp function. It returns a string. It basically kind of gets the date and the time, and it puts that into the file name. We'll put our code in here, and this is the if statement that kind of turns it off. And then we have two key presses. One is to record a single frame PDF, and one is just to save a JPEG. So we might want a JPEG of it just to have it. So that's the functionality that's set up right here. And I have my file here that I'm going to use to draw with. Okay, and actually I think the proportions are a little bit off. I think it should be 600 by 800. Okay, so we have this set up. Let's kind of go through all the steps again. We have PImage. We're going to set that up. Maybe we'll have a cell size here, and we can change this. We're going to have our columns and rows. So I'm going to use the code, roughly the code that was in the previous example. I said I wanted to use sine and noise, so I'm going to bring in these values. So I have theta and t because those I want to increment those. Okay, in the setup, let's load the image. So Stella.png, we're loading the image. We're going to set the columns. Remember, we're going to divide the width by cell size. Rows is equal to height divided by cell size. Okay, so we got that going. Let's see what else we need. We have a background here. I said earlier I want to load the pixels into the array. Okay, so load pixels. And from here, we're going to use our for loops to go through all the pixels, or not all the pixels, but go through and selectively get the color. So we're going to start with I is equal to 0. Now we're going to use columns in this case, and then we'll do a conversion down here. So the conversion, let me also do J. So this is going to be the rows. And I want to just nest those, right? So yeah, there we go. Okay, so the X value is going to be I times cell size. Because I is the number of columns, so times cell size, that's going to give us like the X position, plus cell size divided by 2. I'm doing that so I'm like shifted over a little bit. So this is going to be X position, int Y is equal to I, or J times cell size, plus cell size divided by 2. So that is the Y position. Whoops, I didn't put semicolons at the end. Okay. Now, to access the pixel array, we want to, whoops, have this other variable. Now we said X plus Y times width. That's the sort of pixel array location or index. Let's grab the color from there. So we'll get IMG, and we're going to grab the color pixels. Perfect. I think that will be good for right now. Let's start with now we're working in 3D space, right? So we're going to have to use translations here to move things around. We'll start with push matrix to save our position. Let's translate this over X, Y. I haven't set up a Z yet, but actually, let me think about how I want to do this. What I'll do is I'll create a Z. I'll use a float right now so that it gives me a little bit more flexibility. I'm going to map the brightness. So what's going to happen is the brighter the pixel is, it's going to be in a different spot. So I'll grab the brightness of the pixels. So we're grabbing this kind of same thing, but we're running the brightness function on it. Okay, so we'll grab the brightness, and then we'll remap this. Now the brightness, the lowest it'll ever be is 0. The highest it'll ever be is 255. And we're gonna map this into Z space, right? So let's start with something really. Let's kind of start with a big range, like maybe on one end it's negative and maybe on the other it's like 500. Let's start with this. So we're translating X, Y. We've already done that in Z. Okay, so that's translated over. Maybe we can do maybe we'll start with an ellipse here. And since we translated everything, we can just set it to 0, 0 because it's already been shifted by being translated. And let's take maybe its cell size times 2, so it's a little bit bigger, just so we can see it. And at the end, let's pop the matrix back out so that we're not continually like moving and translating. I think that will be enough for us to just see if this is working. I haven't done the sign and the noise yet, but I just want to make sure that I'm reading the image, and oh, there we go. So nothing's moving, but you can see I'm in. Okay, I'm in the Z space. The brighter pieces are closer to me and they're bigger. That's why it looks like this. Nothing is moving. I forgot to turn off the stroke. Or maybe I like that stroke like that. You know, if you're building your portrait out, maybe that's something you want. You could, and again, think about ways that you could mess around with this. Could you change the color? Could you change the stroke? Could you move things around? Okay, so let's now start to add some more elements. I'm going to turn off the stroke. I don't really want the stroke there. Now, let's see, maybe we want to put some sine and cosine in here, or maybe just sine. So maybe what I'll do is I'll have it move around. So maybe I'll say plus sine of theta times, maybe it's 500, because this is 500. So it really moves. Oh wait. Before I do that, I also want to make sure I'm incrementing theta somewhere, right? Otherwise, I'm not going to see a difference. So let me put theta plus equals 0.01, maybe, something like that. Let's see if that sine now is going to change the depth. There we go. So we have a sine wave that's pushing all these things out, and then now it's kind of pulling them back in. So that, imagine that wave kind of going down, and what it happens is, yeah, it starts to coalesce, and we have a portrait here. If we wanted to save this, we could press a button and save it. Yeah, so that's one thought here. Why don't we add some noise to this? So plus equals 0.01. Okay, so where could we put in the noise? This is something to think about. Let's try to affect the color of this. So one thing that's happening here is this color variable C. It already holds the red, green, and blue values, but if we wanted to kind of mess with the red, blue, and green values separately, maybe one thing we need to do is, I'm gonna grab this. I'm gonna kind of reset this. So I'll say like I could call them separately. Like I'm gonna grab image.pixels. Okay, so this is gonna pull the red from there, and if I wanted to pull the green, it's basically doing the same thing, except I'll do green, and then the blue is the same. I'm copying and pasting that there, so it's gonna it's gonna find out those values. If I run this, it should look exactly the same, but what's nice here is I can start to like add in noise. Maybe I'd throw in noise here times 20, because noise only goes from 0 to 1, so that you wouldn't really notice anything. You could put, maybe here I'll do minus noise, so noise T times 40. It creates like a more pronounced effect. Let's see what happened. I forgot. Looks like what did I do here? Oh, I'm missing a parentheses there. Make sure I close that out. Oh, and make sure, sorry, I messed up here. I gotta close that there. Oh, I put those things inside the parentheses, my bad. So this is the red right here, and then we add that noise onto it at the end. Okay, so sorry about that. Went in the wrong direction. Oh, and it's still acting up. Oh, there's a random bit right there. Okay, let's try to run that. There we go. So there is some noise here. Looks like there's maybe like too much red here. It's probably because I'm subtracting a lot of the green that was there. And actually, let me make the increment bigger so that you see more like fluctuation. I just want to show you this effect of using noise in here. Yeah, it's pulsating a little bit. It's moving around. Maybe what I want to do is, if I want this to move a lot more, I could put it inside the for loop so that it changes a lot for each one, and I think that will give it even more, because this happens each time it runs through the for loop. I think this will give it an even crazier jittery. Yeah, it's kind of like blinking. I'm not sure if you can see that well. Maybe I will add a increase the number here so that you can see this. Okay, now you can see it's moving around. So yeah, that's one thought, and let's just keep playing around with this. Like if you wanted to do rectangles here, maybe that's something that you could do as well. 0, 0. I'm just going to comment that out and run this. So here it is with rectangles, and maybe those need to be bigger, but you know, from here, you know, you could also start to rotate it. Maybe you rotate it by T. That's that value. I'm kind of throwing some things into here. This will probably be a little bit too crazy. Yeah, that's, you know, that's moving around. That's a little bit too fast, maybe. Anyways, I'm messing with it. You could maybe put in some 3D forms. So I think there's you could throw in a sphere here. Maybe sphere cell size. What does that look like? This might take a little while. Okay, these are spheres, but I guess they look like circles. One thing you could change here is there's a function called sphere detail, and I could make it a lower detail, and maybe maybe I want to throw in some lights into this, so that I'm going to throw it up outside the for loop, because I don't want to draw tons of lights. I just want to put a light in here and maybe see some shadow. Again, we're in 3D. There we go. So now you can see that there's it's kind of dimensional. The sphere detail is low, so it looks more kind of like a polygon. That's what that looks like. I mean, you could just put some random numbers in here. Maybe it's 3 to 8. This is going to be probably too much movement going on, but let's mess around with it. There we go. It's like kind of iterating. All right. So you should try to create your own algorithm or your own way to kind of take an image and create some sort of abstraction or create some sort of portrait out of it. We're using image processing here, and we're getting a different result. Okay.